over 3.1. Anything you need cleared up over 3.1. Anything over 3.1. That easy? Good. That was D. Periodic functions. It's like I said, it's the entire unit. The entire unit. Everybody okay? Nothing? 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 Yes, sir. I hope so. G, this one? This question right here? Sorry? This question? Number 10? The graph of G is periodic where G of X plus 10 equals G of X. So what they're telling me, if I have G of X plus 10, it's periodic every 10 units. Every 10 units. So if I add, let's see, at 4, it's going to be the same thing. At 10, it's going to be this. At 13, it's going to be this. At 23, it's going to be that. So they want to know what it is at 27. So this is 7. So 10 more and 10 more puts it at, so it's at 5. Right? I don't think there's a whole lot of work to be shown on that. That's why I don't know if you did it or copied the answer. Right? I guess you could do 7 plus 10 plus 10 equals 27. I don't know. Or 27 minus 10 minus 10. I don't know. So negative 7. If I add 10 to negative 7, I'll get 3. So I should be at negative 2. Oh, G of 10 of 10. That's a composite. So G of 10, I guess I would subtract 10. I would get 0. So this is the same thing as G of 0. And G of 0 is 4. So then I got to do G of 4. I don't have a 4, so I got to add 10 to 4, which that'll give me 14. I don't have that, so I'll subtract 10 from 4, and I'll get negative 6. So this should be 1. That's a big one. Minus 3. So if I add 10 to negative 3, I'll be at 7. So this is 5. If K is 1, then I'll be at G of 7. If K is 1, I will be at G of 7. G of 7 has to be 5, and then doesn't matter what K is because I'm adding 10 to it. Yay? Easy peasy lemon squeezy? Yes, sir. D for number 9. Worksheet D, number 9? No. Oh, question D on number. I got you. This one here? Okay. So 7, Kate, bless you. So the period is 7. So guys, really, if the period is 7, that part of it almost doesn't matter. I mean, if K is 0, because if 0 is an integer, 1 is an integer, negative 1 is an integer. Fractions are not integers, right? So if K is 0, this is the same thing as f of 4. And I don't have a 4 up there. But if I add 7 to 4, I'll be at 11. I don't have an 11 up there. If I add 7 more to 11, so I need to go the other way. So I'll subtract 7 from 4. If I subtract 7 from 4, I'll get negative 3. And so if K is negative 1, that will be negative 1 times 7, which is negative 7. Negative 7 plus 4 is negative 3. That will be equal to 4. And it doesn't matter what K is because it repeats every 7. So when you see that, guys, really you don't have to look at this part of it. It's the same thing as this if f was 4, f of 4. Does that help you? So that's why on this other one on letter D on this one, I really didn't care about the 10K. I just looked at the -3. And I don't have a -3. So I add 10 to -3 and I got 7. So I can use that one. But the 10K, this 10K and this 10, they're kind of like, now if they did 7K or something, we'd be in trouble for this one. If they did 10K on the other one, I'm in trouble. It's like, I don't know what those are. Yay? Anything else? Anything. Y'all okay on the C's and D's and was it B? Oh yeah, any one of those? Y'all okay? Like I said, we only did the C, did we? Is that right? You only had to do the C. There is a D and an E. If they gave you issues, or when it comes up to get ready to test time, I might want to look at D and E and make sure you can do those. Because I'm telling you, that is a free response question on the test. And you're probably going to see a F, G, J, K, and P. And I don't know why they use those letters, but they do. And they're going to do T and H of T, and they're going to do all kinds of things. Hopefully those were not too bad for you when you see them. Sometimes they'll be negatives, and sometimes they'll be positives. But that is a free response question on the test. Why is that asterisk? Because I'm writing on it. These are more of a multiple choice type questions. What the heck going on here? Huh. Okay, we're good? We're good? Chit chat for just a little, well, chit chat now. Remember the other day we started the unit circle? So we're going to talk about it a little bit more. That should be, I'm telling you, not yet. Maybe not next week, but at some point that's got to be, you just got to know it. Just like you got to know your multiplication tables, you just got to know that unit circle. You got to know it. Okay? So I know we talked about a dog and a duck, and I don't have a blank paper. I'm going to use this thing. I don't like for you to memorize it. I really don't. You can, but I would just rather you know it. There's a difference. Knowing it and memorizing it. I don't think memorizing it makes you understand it. Like, do you know that the square root of 4 is 2, or have you memorized that the square root of 4 is 2? There's a fine line between the difference. But just, oh, there it was. Oh, you weren't supposed to do that. You gonna fix it? Yeah, close enough. Should be a circle, not an oval. Unit circle. Unit circle. It's always centered at the origin. There is an equation for circles. I don't know if you guys, did y'all do circles in geometry? Equations where you centered them, moved them left, right, up, down, and y'all didn't do ellipses. Y'all just did circles, right? Conics is what we call them in pre-cal. Ellipses, which that's actually an ellipse because it's not perfect. Ellipses, hyperbolas, ellipses, hyperbolas. What's the other one? Ellipses, hyperbola. There's another one. Anyway, that's all chapter 4, unit 4. We don't get to it. Anyway, you know that circles are two different ways. X squared plus y squared equals a radius, right? That's the equation of this unit circle because it's 1. The radius is 1. And it's not shifted left, right. So that's why there's nothing with the x and there's nothing with the y because it's centered at the origin. So I don't know if this is a pre-cal question, but I think you need to know that that's the equation of that unit circle. And out of that unit circle, we have 1 point, 2 points, 3 points, 4 points. And because it's a unit, that point is 1, 0. That's like the easiest point in the world, out to 1 and up to 0. And this point is 0, 1. And this point is -1, 0. And this point is 0, -1. That's easy. Those are the easy ones. But those are 1, 2, 3, 4 points you got to know for the unit circle. You just got to know those. And then we talked a little bit about shooting my duck at a 45-degree angle, right? And it's no longer a 45-degree angle. That is now pi over 4. It's radians. So instead of that being 45 degrees, pi over 4. Remember, it's 2 pi all the way around. It's the circumference of a circle. The circumference is 2 pi r, where r is 1, because it's the radius. That's a unit circle. So 2 pi is all the way around, so halfway is pi. If halfway is pi, then half of that half is pi over 2, because that's halfway. And then half of the half of the half is 1/4. So that's pi over 4. That's 2 pi over 4. Here's 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. And then we can just keep going. I mean, you can do 27 pi over 4. You could see that. But 27 pi over 4, well, that's 8. That's another 8, which is 16. That's another 8, which is 24. 25, 26, 27 pi over 4 is that angle right there. So, and then we talked about negatives. And you can go down for negatives. Ups are positives, downs are negatives. Counterclockwise is positive, clockwise is negative. But I think it's easier to talk about down and up. Up is positive, down is negative. That makes more sense. Down is negative, up is positive. And I can go down to get to this angle, or I can go positive to get to this angle. So every one of these angles has infinite ways to label it. I can label this angle, 1, 2, 3, 4, 5, 6. I can name it 7 pi over 4. I can name it that way. And I can go 8 pi more, so I can name it 15 pi over 4. Or I can go 8 pi more, and we can go 15, whatever that is, 23 pi over 4. Or we can go negative pi over 4. So however you got it, there's infinite ways to label those angles. Infinite. Okay? But what you guys have to know, that part of it, but then you also need to know that this point right here is the square root of 2 over 2, and this is the square root of 2 over 2. That's what that point is, because this makes a 45-45 right triangle with a hypotenuse of 1. And to get to this side over here, you have to divide it by the square root of 2. And when you divide it by the square root of 2, you have 1 over the square root of 2. And 1 over the square root of 2 is the same thing as the square root of 2 over 2. And you just gotta know that. Any of these 45s, I call them the 45s, but the force, they're the same thing. It's square root of 2 over 2. Just sometimes it's positive and sometimes it's negative. Those are the x values, these are the y values. Okay, and then we started talking a little bit about the trig part of it, and we had sine and cosine. And sine was my duck, or the y, and cosine is my dog, which is the x. How far out does the dog have to go, and how far does the duck fall? And so it's the square root of 2 over 2, and that's the square root of 2 over 2. And if it's down here, that's the square root of 2 over 2 and the square root of 2 over 2. However, x is positive and y is negative. In quadrant 2, x is negative, y is positive. And in quadrant 3, x is negative and y is negative. So whatever angle I give you. You guys, you just got to know it. Are you going to change pages? It's been a while since I've used this program. Yeah, there it goes. I don't know why it's dotted. Edit. Edit. Pages. Nope. View. Grid. Nope. Layout. Nope. Where's that at? Tools. Nope. Settings. I don't know. Topic. Nope. Insert. Nope. Tools. Who cares? Okay. So you're going to see a trigonomic function, sine or cosine, right now. Let's just go with sine or cosine. Sine. And then they're going to give you some angle in radians. I don't care what number I put up there. This answer is going to be square root of 2 over 2. It's just your job to figure out if it's positive or negative. I don't care what number they put up there. If it's power of 4, it's the square root of 2 over 2. This is the square root of 2 over 2. And you just have to know this. You just have to know this. 1/4. If you have to draw it, draw it. 1/4 right there. That's square root of 2 over 2. And if I put 17 power of 4, it's square root of 2 over 2. You just got to figure out if it's positive or negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Same thing, same angle. Same angle. So it's square root of 2 over 2. Good enough for that? I'm not going to do 97. Let me do this. Erase. Negative 5 power of 4. 1, 2, 3, 4, 5. Sign falls straight down. That's positive. You are in quadrant 1. You are in quadrant 2. Sign is positive. Sign is positive. Sign is positive. Sign are the y values. Positive, positive. Negative, negative. Yay? Okay. Any fourths. I don't care if it's sine. I don't care if it's cosine. It's square root of 2 over 2. Any fourths is the square root of 2 over 2. That's nice. So memorize it, know it, whatever. Because you cannot go to your calculator and punch in sine of 5 power of 4 and hit enter, and you will not get square root of 2 over 2. You're not. So you got to know it's the square root of 2 over 2 because it's going to say find the exact value. I think my calculator does square root of 2 over 2, though, now that I think about it. Experience not optimized. Okay, whatever. I understand. Oh, that's not what I want. Leave. Oh, this is what I want. Sine of 3 pi over 4. Yeah, mine does square root of 2 over 2. TI does not. I don't think Desmos does. But it might. I don't know. But you know it now. Any force is square root of 2 over 2. Back here. Back here. Where am I at? This thing. Any force. Just your job to figure out if it's positive or negative. Y'all okay with that, right? Okay, now the tricky part. The tricky part. Oh, didn't connect. It's all right. The sixth. The sixth. 1/6, 2/6, 3/6. I broke this up into sixths, not really thirds. It's the same thing. 1/6, 2/6, which is 1/3. 3/6, which is 1/2. 4/6, 2/3. 5/6, 6/6. So we only have choices of 1 pi, 2 pi, 3 pi, 4 pi. So no fractions. This is 1 pi. Here's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, -1, -2, -3. Y'all okay? Good? So if you don't see a fraction, you're on the x-axis. If you don't see a fraction, you're on the x-axis. No fraction, you're on the x-axis. 1 odd, you're over here. Evens, you're over there. And that's -1, 0, or 0, -1. Ducks on the water. Ducks on the water. Duck is sine. Sine doesn't go anywhere. So sine is 0. There and there. So if I put down sine and you don't see a fraction, you see 27 pi, 0. 0. Because you're going to end up over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 27. Sine is 0. Cosine is -1. Because it's over here. Cosine is -1. So cosine's -1 or +1, depends on which side you end up on. So no fractions. No fractions, you're here or here. Halves, you're either here or here. One of those two. One of those two. Positives, you're going up. Negatives, you're going down. And you count them. Count them. And the halves is where cosine is 0, because the duck falls right into the boat, right? Cosine doesn't go anywhere. But sine's 1 up here and -1 down here. So 1/2, 3 halves, 3, 4, 5. One half, 2 halves, 3 halves, 4 halves, 5 halves. Yay, okay? All right, so, sorry, I tangented. Eraser. So now I'm at the sixths. These are the only ones you got to know. Only ones you got to know. Only ones you have to know. Because it's the 30, 60, 90, 45, 45, 90, and everything else we don't know, we can't find. That's 1/2, and this is a square root of 3 over 2. So 1/6 you just got to know that. 1/6. You barely went up. So that distance is a short distance over there. And cosine is longer than that fall. Whereas when you're 2/6, now this is the short and this is the long. That's 2/6. This is a square root of 3 over 2. Okay? Yes, no, somewhat, maybe. I don't know what tricks you want to know to memorize it. I don't really care if you get the test and you write down the unit circle and write down the whole thing. I don't write down until I know what I need less. In other words, if I'm asked what sine of, I don't know, 17 pi over 3 is, I go to 17 pi over 3. I got to make it a 6 first. 34. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just keep going until I end up at 34. Or that's 12. 12 pi over 6 because it's 2 pi. 12, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. That's where 34 pi over 6 is. And sine is the long one. So it's square root of 3 over 2. And sine's underneath, so it's negative. Talk to me.
Wouldn't you just say that the sine of something over 3 doesn't simplify down to 6?
Yes. To me, that's memorizing it almost, but when after you do this a lot, you won't have to do this. You just got to know it. You just got to know it. And I do this different. There is no doubt that I do this different than any other. They'll teach you kinds of tricks, and I just want you to know it. So if you want to know tricks, there's a whole bunch of them. You only have, you can't guess anything except a 0 or a 1, positive, negative. Square root of 2 over 2, positive or negative. 1/2 or square root of 3 over 2. Those are the only options you have. Those are the only options you have. Everything else we don't know. We have to use a calculator. We have to use a calculator for everything else. So if you see something like, I don't know, sine of, 7 pi over 8. How about that? Nobody knows what that is without a calculator. We have to use a calculator for that problem. The halves, the wholes, the thirds, and the sixths, we know. We know. Everybody okay? Stay. Unit circle. Yay? 4 quadrants. I'm going to give it to you, but I don't care if you fill the stupid thing out or not, to be honest with you. Good enough. That angle, that angle, that angle, that angle. 3 more times. That's the unit circle. You got to know every one of those. You got to know every one of them. Yay? No? Good? It's either going to be a 0 or a 1 or a square root of 2 over 2 or a 1/2 or a square root of 3 over 2. And if this is the short, that has to be the 1/2. If it's this distance, it has to be the square root of 2 over 2. And if it's this one, it has to be the square root of 3 over 2. This has to be the square root of 3 over 2. This has to be the square root of 2 over 2. And this has to be 1/2. And it can happen here, it can happen here, here, or here. All it does is change positives and negatives. And you can have negative angles, but it can only happen here, 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 or here. Good enough? So at some point, pretty soon, we're going to have a little quiz, and I'm going to ask you for sine and cosine of any one of those angles. And like, I may give you 10 of them, and I'm going to give you like a minute to do all 10 of them. That's how fast you got to know them. That's how fast you got to know them. I'm not going to give you a minute to do 10 of them, but kind of understand what I mean, right? And rather than you draw a stupid thing and have it, you just got to know it. You just got to know it. And what I always did, I just drew it every single time. I just drew it, and I drew a circle, and they all started looking bad, but I tried to figure out where the angle was. Is it in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4? And if it's closer to the y-axis, then this has to be the long and that has to be the short. And if it's closer to the x-axis, this has to be the short and this has to be the long. And if it's right in the middle, it doesn't matter because they're the same. Yes, no, somewhat, maybe? Okay. Here we go. 3.1. I'm sorry, 2. 3.2. So that 3.2 we're going to talk about today. Guys, I don't see you again until next Monday, right? Friday is another B day. We're going BB. So I see you today and that's it. I'm not going to see you till next Monday. Some of you are not going, like I said, you got to start doing a little bit better on our homeworks. A lot of you guys are doing really good. I really think this is an easy unit, but you got to do your work. If you don't, it's not. It's going to be so easy, you're just going to leave it blank. Okay. In this course, we're going to approach angles in a way that may be different than what you've seen in the past. We will approach angles in a generalized method that allows us to view them through periodic lenses. To do this, we must first make clear few definitions. One, standard position. So anytime we're talking about standard position, we're talking about on the x-axis. That is the standard position. That's the initial position. That's where we always start. We always start at the origin and we go out the x-axis. Okay, we go out the x-axis. And then the terminal, kind of morbid, but that's where you end up. Your terminal, you're done. Terminal ray, so y'all know what rays are. Rays are points on one side and they are lines that just keep on going forever. The terminal is where you end up, where it ends, where it stops. The terminal is the second ray of an angle in standard position. So if this is the standard position, there's the terminal, I end up in quadrant 2. Immediately you should think in your head, okay, I'm in quadrant 2, sine is positive, cosine is negative. Sine is positive, cosine is negative. There's the standard, yada, yada, yada. Okay, whatever. So sine, cosine, and tangent. You already know this. That's what's kind of nice. Except they're not going to give it to you as so, ka, toa. They're going to give it to you as y over r. Y is the y value. It's the opposite. Y is over here. That's the opposite. Your angle is always on the origin. So y is the opposite and r is the radius, which is the hypotenuse. So you guys are lucky in the fact that you already know it, you just don't know it the way that they're going to tell it to you. You already know that sine is opposite over hypotenuse. So they're going to say it's y over r as opposed to opposite over hypotenuse. And then they're going to tell me cosine. I don't know why they put the x. I don't like that. I wish they put the x down here. It's the same distance, but I wish they'd put it down here. The adjacent over the hypotenuse. And it's x over r. And in tangent, we know is y or opposite over adjacent. Opposite over adjacent. Okay? And so sine is the ratio of the vertical displacement. Again, a bunch of weird words, but don't confuse it from what you already know. The vertical displacement of P from the x-axis to the distance between the origin and point P. Point P, right there. Boom. Uh-oh. That's that distance. It's the radius. Cosine is the ratio of the horizontal displacement. K-A-H. Tangent is the slope of the terminal ray is the ratio of the vertical over the horizontal. Tangent is also, not only is it opposite over adjacent or y over x, but tangent is also sine over cosine. Tangent is sine over cosine. You got to know that. You got to know that not just tangent's y over x, but tangent is also sine over cosine. Okay? Tangent is also sine over cosine. Example ad numero uno. Again, I don't like that they drew this. I do. I guess they did it to not confuse it with the, so you can actually see the dots, I guess. I don't know. This point now, look, it's 3, 0. 3, 0. 3, 0. That means the radius is 3. It's not a unit circle anymore. It's a, I don't know, tricircle. I don't know. So if the radius is 3, that means the hypotenuse is 3. The hypotenuse is 3. Always. The figure shows a circle centered at the origin. Watch what it says. Centered at the origin. In standard position. Oh, theta is in standard position. That's theta. We use a lot of Greek letters for angles. And theta is one that we use a lot. Don't do it like that. That looks like 0. Theta. Theta. Whatever. I just do theta. Anyway, if you don't like theta, then do something else. The terminal ray of the angle intersects the circle at point P. Intersects the circle at point P. The coordinates of P are x, y. Okay, x, y. Duh. Which of the following is true about the cosine of theta? I don't think you needed me or anything else in this class to be able to answer that question. Because you know that this has to be 3 because this is 3. And if this is 3, this is x and this is y, because I don't know what it is. But because I don't know what the angle is. But cosine is the adjacent over the hypotenuse. And so cosine of theta has to be adjacent over hypotenuse, x over 3. It has to be. Cosine is x over 3 because it's the ratio of the horizontal displacement of P from the y-axis to the distance between the origin of P. I like that answer. It's not y over 3 because cosine does not go with y. Cosine goes with x. Cosine is not y over x because that's tangent. And cosine is not 3 over x because that's hypotenuse over adjacent. So that's why my answer is A. Again, when you're doing these, I'm not too concerned with that you know that that's the right answer. Not that that's only the right one, but why the other ones are wrong. That's how you should be doing these if you want to really learn it. Y'all okay with that? Good enough? I don't think you needed me to learn that. Ooh, they're going to try to trick us. The figure shows a circle with radius of 5. Five. Duck. Boom. The terminal ray intersects the circle at point P. Amazing how they did that. Find the following values. This is y. This is x. Sine of theta is y over 5. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Uh-oh. I missed 2 of those. Somebody in this class is going to miss 2 of these. I missed 2 of these. Anybody tell me which 2 I missed? Which 2 did I miss? Hit me. A and B? I got B right. Hit me. Why did I get A and C wrong? I did. I got A and C wrong. Hit me.
What gives you X and Y values?
Oh, it does give you X and Y values. Oh. Shucky ducky quack quack. Because it's a 3, 4, 5 right triangle. This is 3, because this, see there's 3 and 4. That's this point up here is 3, 4. What's this point down here? 3, -4. 3, -4. So this is 3 and this is -4. I thought I missed it because that should have been a negative y over 5, and I thought that should be negative y over x. Somebody else caught it that I actually know what x and y are. So this is no longer y. This is now -4. That looks like some of your -4s. I'll just leave it like that. There, fixed it. X is not x. X is 3. Y is not y. Y is -4. X is 3. And on a negative, guys, you can put negative on the bottom, or you can put it on the top, or you can put it out to the front, and they don't care. Don't put it on both. I like to put it with the top number. They don't care. Everybody okay now? So I knew those points. I knew those points. And they could have put it in quadrant 3. They could have put it in quadrant 2. If it's quadrant 2, that's where we would have the -3, +4, and in quadrant 3, both of them are negative. And if they're both negative, that will make tangent positive. Beautiful. Oh, yucky ducky. What the heck we got going on here? So I got a P, and I got a Q, and I got an R, and I got an S. The figure shows a circle, radius r, centered at the origin with an angle of measure theta. In standard position, the terminal ray of the angle intersects the circle at point P. Right there, x, y. The coordinates of P are x, y. Just told me that. The coordinates of Q, R, and S are a result of reflecting P across the Y and the origin and the X. Reflected across the Y, reflected across the origin, reflected across the X. Beautiful. Find the coordinates of Q, R, and S in terms of X and Y. I'm glad they didn't tell me in terms of numbers because I don't know numbers. So Q should be really easy because Q is just like P, except Q has to be a negative X. So this is negative X. I need a pencil. Negative X, but Y is still positive for Q. R, pretty easy. They're both negative. Negative X, negative Y. And S, X is positive, but Y is negative. Man. I hope you think this is really, really easy. I hope. Because it is. Find the sine of an angle whose terminal ray intersects the circle at point S. Find the sine at point S. Point S. Right here. R. This is negative Y. This is X. You're going to miss this because of negatives and positives if you're going to miss it. Negatives and positives, just be careful. You already know you're going to sine is negative in quadrant 4 because the duck is underneath the water. It's underneath the water here and here, so it's negative anywhere. So what do we get? Negative y over r. Negative y over r. Find the sine whose angle, whose terminal ray intersects the point at S. Find the cosine at Q. So I got to go, what the heck? What's going on? I don't want to print. How did that happen? No? What? Cancel. There we go. Whoops. Where's Q? Quadrant 2. Dog had to turn around to go get the duck. Negative. You don't need to know all that stuff. If you're going left, it's negative. But sine's up in there, it's positive. You already know all that stuff. Every x is negative here, every y is positive here. Cosine, negative x over r. I like to see, whoops, I don't know why I have r right there. Cosine theta equals, I like to see sine theta equals. Is this going right with your notes? I didn't ask that. Y'all okay? I'm sorry. Y'all know to tell me because I get my notes differently than y'all's. Find the tangent at R. Somebody just tell me, where's quadrant? Where's point R? What quadrant? Third quadrant. So tangent's negative in quadrant 3. No, tangent's positive in quadrant 3. 1, 2, 3. Tangent's positive because both sine and cosine are negative. If sine and cosine are negative in quadrant 3, tangent has to be positive. So tangent of theta is negative y over negative x, but I would like to see just x or y over x. I don't think they'll count you wrong for it unless they say simplify. Ooh, now they're not going to draw it for me. Is this the last one we have? Holy cow. So there's 3.2. 3.2 is broken up in twice. The unit circle stuff happens the second time. But I just wanted to teach you today. It's my favorite thing to teach because it's so easy. Maybe not for you yet. It will be. Theta, be an angle whose terminal ray coincides with y equals negative 3x in quadrant 2. Okay. Negative 3x, down 3 over 1, down 3 over 1, down 3 over 1. With a y-intercept of 0. So down 3 over 1. Down 3 over 1, but I don't think I need that many. What quadrant? Oh, it's in quadrant 2. So if I go down 3 and over 1, I'm in quadrant 4. I don't want to do that. So now I want to go up 3 over 1. Up 3 over 1. I always connect the triangles to the x-axis. You don't have to. It's just recommended. If I connect it to the y, that's still negative 1, and you still have a right triangle. It's a much better habit to connect it to the x-axis. You'll thank me later. If that's 1 and that's 3, that's 9, that's 10, that's the square root of 10. The radius is always positive. Always positive. There's never a negative radius. Never. You can have negative angles, you can have negative x's, you can have negative y's, but radius is never negative. And now I want the sine and the cosine and the tangent. And sine is negative 1 over the square root of 10. My guess is they do not want that answer. So you'll need to multiply. What, did I do something wrong?
Sine is, that's
Oh, that's cosine, isn't it? See? See what happens? Change it to positive 3. That's a pot. Don't look at me like that, Jonah. Does that not look like a positive 3? You ought to see some of the crap I see from you guys. I'm not talking about you now. You have beautiful handwriting. It's the guys. I don't know, Lake, yours is not the greatest either. Sorry. Okay. If you don't like me saying it, then fix it. Thank you. 3. Here, I'll do non-hieroglyphics. Okay, I don't think they'll like that answer though, so I'll multiply by the square root of 10 over the square root of 10. I don't know. I don't know what the answer is going to say. Probably going to be a multiple choice. And they will not have this and 3 square roots of 10 over 10. They will not have that. But if they don't have this, that's probably what they have. Square root of 10, square root of 10. So this is 3 root 10 over 10. Cosine is negative 1 over root 10. Just be careful about your negatives and your positives. If they're going to try to trick you, that's where they're going to try to trick you. It's not going to be the wrong side. It's just going to be a negative and a positive. Negative square root of 10 over 10. I've already simplified it. And then tangent is opposite over adjacent. And if you want to put it over 1, you can. Yes, no, somewhat, maybe. SOHCAHTOA is all it is. The unit circle, that's what we're going to do on Monday. Just start getting it in your heads. Zeros, ones, 1 square root of 2 over 2, square root of 3 over 2, or 1/2. It's either zeros or ones, and it's over 2. It's either the square root of 2 over 2, square root of 3 over 2, or 1 over 2. If it's the 45s or the force, it has to be square root of 2 over 2. If it's the 30s or the 60s, it has to be a 1/2 or the square root of 3 over 2. Which one's shorter and which one's longer? Did sine fall further than cosine had to go get it? I don't know. Yay? Good? Okay, so I'm going to give you some homework over 3.1. And a bunch of you knuckleheads, I'm sorry, I keep saying 3.1. 3.2. A bunch of you knuckleheads didn't turn in 3.1. Make sure you get those turned in. You don't want this stuff building up on you guys. This is new to every one of you guys. Maybe not new to every one of you guys, but it's new. Everything else we've done this year has been Algebra 2. We've extended it a little bit. Exponentials, polynomials, logs, all that stuff's Algebra 2. This is not Algebra 2. Yay? Woo!